It's math time with Heinz. It's math time with Heinz. Math time.
Good morning, everybody. Lesson 2 here. We're going to talk about adding and subtracting polynomials. So yesterday we talked about what a polynomial was, and today we're going to practice adding and subtracting, which is really just combining like terms. So today we're really combining like terms is our whole goal. We're going to talk about what like terms are and how to do it. So find the sum of the following polynomials. So yesterday we used that method of stacking the like terms on top of each other, just like we added with our standard algorithm, where we stack the terms on top of each other and added together. So -3 and 4 is 1. 9 minus 5 is 4x. Remember, we don't touch the variable. The variable just comes along for the ride. -4 plus 7 is 3. So that right there represents the sum. And then I ask you for the degree, leading coefficient, and constant. So the degree is the highest power. The highest power here is x squared, so 2. The leading coefficient, who goes with that highest power? What's the coefficient of that term? 3. And the constant is that plain old number of 1. So this was just to get us back into the swing of things of how do we add polynomials? Well, we work with the coefficients. We don't actually touch the variables. The variables just tell us who are like terms that we can add together. So rewrite each expression in standard form. So stacking them on top of each other is great, but I kind of like to just look at it and find the sum. So I've got 2x squared. I've got -3x squared. So how many x squareds do I have? Well, 2 minus 3 is -1x squared. I have an x to the third, -1x to the third, plus 1x to the third. Those guys add to 0, so they're gone. I don't need that x to the third term because there's 0 of them. -9x and 7x is -2x. Oh, I have an x to the fourth term. But he can't add with anybody because no one else is x to the fourth. Now I'm going to put that all the way out front here. Because remember, I want it in standard form, where my variables go from the highest power down to the lowest power. And then I just have that +1 to stick on at the end. So there is the sum. So it's a little bit easier than stacking them on top of each other and lining like terms up, because you kind of just read through and find who you used and who you haven't used. All right, let's look at this next one here. 2x squared minus 2x squared. Well, if I have 2x squared minus 2x squareds, I have no x squareds. I have 0 of them. I could write 0, but that's just silly. 3x's minus 2x's is 1x. And then I just have a +1. So that 1 out front's a little silly to write. So the real answer is x plus 1. 1x plus 1. I think one more here. So notice this one doesn't have any parentheses, but when we add, parentheses are basically useless. So let's just read through here and find my like terms. Remember, the sign goes with it. 6 minus 1 is 5x squared plus 6x minus 4. There's my trinomial written in standard form that represents that sum. So again, we're combining like terms when we add them. Subtraction, though, has got an extra step. Subtraction has an extra step. And the way that we deal with subtraction is we make an addition. So this polynomial minus this whole polynomial. So the way that we do this is we make it subtraction into addition. We take this factor of -1 and distribute it. And then I add them together. Plus 2x squared minus 1x, +3. So just like that last one where there were no parentheses, once I end up distributing, I don't need those parentheses anymore, and I can combine like terms. So when we deal with subtraction or a difference, we distribute a factor of -1 through and combine like terms from there. 6x squared, -3x, and 10. That represents the sum. Well, it represents the difference, which we turned into a sum. So these next two look very much alike, but they're actually very different. 6x squared plus 5x plus 3 minus 2x squared minus 4x plus 7 versus 6x squared plus 5x plus 3 minus parentheses 2x squared minus 4x plus 7. So here, I'm subtracting this whole thing. Here, I'm just, you can't see what I'm pointing at. On this side, I'm just combining like terms. X squareds, I have 4 of them. I have 1x left over, 5 minus 4, plus 10. No need to write that 1. But over here, it's a subtraction problem. It's that polynomial, take away that second one. So I need to subtract and distribute that factor of -1 through. So everybody's getting a factor of -1. I'm adding the opposite. So 4x squared plus 9x, right? 5 and 4 make 9, -4. Notice they're not equivalent. That adding that set of parentheses in there, if I had parentheses here, it's a very different problem. So that's what we need to look out for is, are we taking our time and following what the polynomial actually says? Subtract 20 from 100. Subtract 20 from 100. So really what I'm asking you to do here is 100 minus 20, which gives me 8. So notice, subtract A from B. When I have subtract something from something else, we start at the back end. We really do B minus A. So subtract A from B, we really read that backwards as B minus A. So when in polynomial land, it really matters. Subtract 3x squared minus 6x plus 4 from this guy. This guy comes first. This, take away this entire thing. What am I subtracting away? This entire polynomial here. Notice I use parentheses, and like we just talked about, those parentheses have an effect on the equivalence of the expression we create. So subtract A from B, we do B minus parentheses A. So I have a factor of -1 to distribute through. Everyone becomes their opposite when I distribute. And now I combine my like terms. How many x squareds do I have? 5 minus 3 is 2 of them. How many x's do I have? I have 9 of them. And then -5. All right, so I'm going to throw this at you a lot, and it kind of just comes back to understanding the language. When there's numbers, it's really easy. Subtract 20 from 100, we say 80. However, when we go to polynomial land, it gets a little bit messier. It's a little bit messier. We'll do one more together, then I'll let you try some on your own. So rewrite this expression here in standard form. So notice I've got some distributive property to apply first here, right? I'm distributing that factor of 3 in. So 6x squared plus 15x minus 18. But here, I'm not just distributing a 4, I'm distributing a factor of -4. -4x cubed minus 4x plus 20. Again, I drop the parentheses. Once you distribute, you don't need, when you're adding and subtracting, you don't need that set of parentheses anymore. So how many x squareds do I have? Well, that doesn't combine with anybody. 15 minus 4 leaves me with 11. Positive 2. Where does this term go? Well, that term's going to go all the way out here in the front because that's the highest power, and I want it written in standard form. Standard form means my polynomial, remember, has to be written with our highest exponents down to our lowest. I want to do one in the OYO with you. this one down here, and then I'm going to let you try those on your own, actually. So we're doing the second row, second column here. So we have some distributing to do, but I'm distributing through a factor of x. I need to multiply everybody by a factor of x. And here, since I'm multiplying, repeated multiplication has to deal with the exponents. So really, what this does is it bumps everybody's exponent up a level. Because how many x's am I multiplying together now? Well, now I'm multiplying 4 of them together. Now I have 3 x's being multiplied together. X times x, x squared. We're going to get that drilled into our head. Repeated multiplication is an exponent. So x times x is x squared plus 2x. And I don't need this parenthesis because I'm just adding. I'm just adding, so I really don't need that set of parentheses. And now we combine our like terms. I have 1x squared and 3x squared makes 4x squareds. 2x minus 1. Okay, so the rest of this OYO here I want you to try on your own. You got 4 problems to try here, and that's what I'm going to have you upload to that Google form. So you got 1, 2, 3, 4 problems for me to do, and I will see you in class.